Hello everyone. In this video I'm going to be discussing isotopes as well as a concept that a lot of students have some issue with at the very beginning in terms of mass number versus atomic mass. And so first, before I actually start talking about that, I need to kind of go over some type of notation so you understand what what your chemistry book is talking about. And you might see some of these on the exams or quizzes as well. So this first notation is what they again includes like all the information you need, but some of it's redundant, and we'll talk about that here in a little bit. So the first thing that you should notice is this giant X. For some reason, they gave like the symbol for the atomic symbol, and so the X is what you would replace anything with from the periodic table. C for carbon, H for hydrogen, He for helium, so on and so forth. The next one, again, I don't know why they chose Z to represent this, but Z stands for the atomic number. And so the atomic number is the number of protons. And so that is the whole number that you will see on all periodic tables. And so the atomic number is the number of protons, but it is also the identity of the atom. And what I mean by that is you cannot change the number of protons. Some of you will still try, but again, you cannot do that. And so the number of protons is the constant in all the universe. And so if I'm talking about carbon better have 6 protons. And if I'm talking about something that has 8 protons, I'm no longer talking about carbon. I have to be talking about oxygen. And so whenever we start working with some of these problems, I might not give you the chemical symbol, but I will tell you the number of protons because it's relatively the same exact thing. And then the last thing we have to kind of talk about in this notation is the mass number. So please, if you're only halfway paying attention right now with this video, open your ears as wide as you can. So the mass number is the number of things that contribute mass. That is it. And so it's going to be the number of protons plus the number of neutrons. Because as I mentioned in my previous video, protons and neutrons are the only things that we're going to contribute or consider contributing mass. Electrons are in there, but as I said, their mass is so negligible because it's so tiny. So the mass number will never, ever, ever have a decimal point with it. And so if you're looking at that on the on the periodic table of elements, you're looking at the wrong number. Don't use that one. And so the mass number has to be a whole number because, as we mentioned earlier, you can't have a fraction of a proton or electron. So in this case, the mass number is only the number of things that contribute mass. So, as I stated before I started talking about this chemical notation has a few redundancies here. Mainly the fact that if I have Z equal to 6, then the X has to be carbon. Because again, only thing that ever has 6 protons is going to be carbon. And if that letter is O, then I know that atomic number has to be 8. Because oxygen has 8 protons and it's always, always, always going to have 8 protons. So another notation that you might see kind of just gets rid of that whole idea. So in this case, you're still looking at the chemical symbol, but now you're looking at a dash with the mass number instead. And so you might be aware of this. I mean, carbon 13, carbon 14, you might have heard about in the past. And so all this becomes important because when we start talking about isotopes, and so isotopes are atoms that have the same identity, the same number of protons, the same chemical symbol, but they have different number of neutrons. And because they have a different number of neutrons, that means they're going to have a different mass number. And so here you're going to be looking at the same atomic symbol, same atomic number, but you're going to be looking at a completely different mass number going from isotope 1 to isotope 2. And so a good example of this is something like uranium. Uranium has a couple different isotopes, 2 of them being uranium-235 and uranium-238. So the uranium-235, remember that 235 does not tell you the number of protons. That 235 does not tell you the number of neutrons. The 235 is telling you the sum or the total of the things that give that thing mass. And so here, if you want to know the number of protons, you would have to look at the atomic number or look at on the periodic table, that giant number on the periodic table that does not have decimal points. If you want to know the number of neutrons inside of your uranium isotope, you would have to subtract the 92 protons from the 235 mass number. And so there is no direct notation for neutrons. It can be determined relatively easy from this notation because it's basically set up as a subtraction problem for you. It's 235 minus 92 equals the number of neutrons. And so, main difference between this, and I'll say it one more time, I'm sorry if I'm begin annoying, but you need to know it. The mass number is just the number of things that contribute mass. Whereas the atomic mass, I'm sorry, I did not come up with a naming system, you just have to live with it. But the atomic mass is actually sometimes more accurately referred to as the average atomic mass. So the atomic mass is going to be the mass of the isotopes, the mass of all of the isotopes. And so what I mean by that is if you were to include every single isotope on the periodic table, it would be way too big to fit on any one wall. And so the way that we kind of get around this is we take the average of all the isotopes of a particular element and we use that as the atomic mass of that element. So the way that this is determined, one thing you have to be careful about is it is a weighted average. And so what I mean by weighted is if you are calculating your grade at the end of the semester and you go through and you just take the average of all your homeworks and your quizzes and your exams and everything else, you're going to be seriously mistaken because if you haven't checked out the syllabus yet, your exams count way more than your homeworks and your quizzes do. And so that's all I mean by weighted is not everything is going to be weighted the same. Not everything is going to count worth the same amount. And so the way we figure out this average atomic mass, or just more briefly named atomic mass, is you take the fraction of each of your isotopes and you multiply them by the mass of the isotopes. And then you just add them all together. For example, if we are going to be talking about chlorine. So chlorine has two major isotopes, chlorine 18 and chlorine 20. And so chlorine 18, not 18 to 20. And so chlorine with 18 neutrons and a chlorine with 20 neutrons. And so I'm telling you that the atomic number of chlorine is going to be 17, and I want you to calculate the average mass of the chlorine. And so the first thing we have to kind of notice, as I already kind of messed up, I have 18 neutrons. That does not mean the mass number is 18. And I have 20 neutrons in my other isotope, but again, that 20 is talking about the neutrons, not the atomic mass. And so the first thing we need to do is figure out what the atomic mass of each of these are. Luckily, I give you the atomic number, which you can, again, scratch out atomic number if you want and write in proton numbers. And so here we have 18 neutrons and 17 protons in our first chlorine. And then we have the chlorine with 20 neutrons. We have 20 neutrons plus 17. So we actually have our chlorine 18 and chlorine 37. And so now if we want to know the average atomic mass of our chlorines, we're going to have to take the percent that is chlorine 35 and the percent that is chlorine 20 and add them to each other. Luckily, I tell you the percents here. So I tell you 75.77 of this stuff is going to be my chlorine 35. And then 24.23% of this stuff is going to be the chlorine 37. And so putting this into math terms, take the mass of your isotope 1 times the percentage of isotope 1 plus the mass of isotope 2 times the mass of your second isotope. And then make sure that do these weighted averages correctly. But beyond that, you need to be very comfortable with doing this kind of stuff because it's going to show up a whole lot in the coming up slides.